All right, good morning. Happy Monday off. All right, so I'm going to go through, like I said, all of these problems from the review we did Friday. This is what your quiz is on tomorrow. So make sure you look through these. The key and the blank questions will be up at the same time as this video in your module for yesterday. I'll get all that uploaded once I get done with the video. Okay? All right, so if you hear anything in the background, my child is just punching holes like his life depends on it in all of my copies. So ignore that. So, all right, here we go. So looking at question number 1, okay, I think it said to evaluate log base 2 1/8. Okay, so remember when we're evaluating, and all this is done without a calculator. So ultimately what I'm going to do here is I am going to set this equal to x, and I'm going to left, right, center that. So 2 to the x equals 1/8. And remember, we want to do this with the same base, and we can make 8 a base of 2. I can make that 1 over 2 cubed, and remember, if it's in the denominator and we want it in the numerator, we just change the exponent to be negative. So basically 2 to the x equals 2 to the negative 3. And once you get the same base, you can set your exponents equal to one another. So x equals negative 3. All right, number 2 is a condensed problem, so we're trying to put this back together into one logarithm instead of 2. All right, remember numbers out front go back up here as exponents, so the first step is going to be to rewrite this log x squared plus log y cubed. And then our middle sign here is a plus, which means it was multiplied, so that's going to be a final answer of log x squared y cubed. All right, several of y'all had questions about problems like number 3, and they should end up being the easiest problems on here for you. So when you're talking about change of base problems, basically they want you to change this from a base of 2 to a base of 10. So all you're going to do is log big over log little, but you're going to do that with a base of 10 instead of a base of 2. Now I'm going to write the 10s, but remember, if we have a log base 10, it does not have to be written. Okay, so literally all I'm going to do here is I'm going to write log base 10 of our big, remember textual big, not value big, term over log base 10 of our little, or our base, which is going to go on the bottom. And then I am going to remove those 10s because you will not see those on any test that we have. And it should just be log x over log 2. All right, number 4 is another condensed problem. So again, I'm going to move these exponents back where they belong. So that's going to first be log x squared minus log y to the 4th. And then this time you're going to see a subtraction sign, which means we were dividing. So our final answer is going to be log x squared divided by y to the 4th. Okay. Number 5 is another evaluate problem. So basically we're again setting this equal to x. Remember, we're an understood base of 10, so if I work that out, it would be 10 to the x equals 0.001. Well, 0.001 is 1 over 1,000. So that's tenths, hundredths, thousandths. So that's 1,000th. So 10 to the x is like 1 over 1,000, which we know that's the same as 1 over 10 to the 3rd. So now we can move that up again. So 10 to the x equals 10 to the negative 3. So x equals negative 3. All right, number 6 is another condensed problem. Exponents are going to move first. Okay, this time we're going to notice we have 2 subtractions. So I'm going to do the first 2 first. So I'm going to divide x cubed and y cubed. Oops. Okay. Then I'm going to divide this as well. So remember, that's going to give me log x cubed over y cubed over z squared. And when we keep, change, flip. Now, some of y'all were struggling with the idea of keep, change, flip. So I am going to write that out. I'm going to write it out up here because I'm going to run out of room. Okay, I'm going to write that out up here. So if we keep x cubed and y cubed the same, we change this big division bar to multiplication, and we flip z squared over 1 to 1 over z squared. Then ultimately what happens is x squared is the only thing left on top for our answer. I'm sorry, x cubed. And then y cubed z squared is on the bottom. So this should be your final answer for problem number 6. Okay? All right, change of base again for problem number 7. So they want a base of 4 instead of a base of 5. So that's all we're going to do. We're going to make us a base of 4. Big over base, big over little. And that's it. All right, so I left, I wasn't sure how much room I was going to need for number 8, so I did leave this blank. If I can fit 10 down here, I will. If not, I'll put it on a different paper. But a lot of y'all were trying, when we were working through this on class on Friday and you were bringing these up to me, you were trying to go ahead and move this to make that the square root of x. And I understand that. The problem is this isn't just a square root exponent here. Okay, so what we want to try to do here is factor out that 1/2 first. So if I factor out a 1/2 from the log 5x, I'm left with the log 5x. So if I pull that 1/2 out, that gets me there. Okay? And then if I factor out a 1/2 from here, from the second term, I'm just left with the 5. Okay, so let's leave the 1/2 alone and let's simplify in here first. So I'm going to go ahead and move this 5 up, and we're dividing, so we're subtracting, so I'm going to divide. So that's going to still be a 1/2 out front, and this is going to turn into log x over y to the 5th. Okay? Now you can move this 1/2 up here. And it's the square root of that whole thing. So it's going to be log square root x over y to the 5. Okay? All right, so let's go to number 9 down here. All right, number 9 was another evaluate problem. Okay, so again, left, right, center. And 81 is 3 to the 4th, so 3 to the x equals 3 to the negative 4, so x equals negative 4. Okay. All right, let's look at problem number 10. Let me go to my next page. All right, so problem number 10. Okay, so we're going to start inside these parentheses first. Okay, so I'm going to start in here first. And again, I'm going to move this 3 up, this 5 up, and I'm going to go ahead and multiply those together. So that's going to be log 3. The 3 comes up, becomes y cubed. The 5 comes up becomes, oops. Let's redo that, sorry. Got ahead of myself. All right, so minus, all right, so log 3. 3 comes up becomes y cubed. 5 comes up becomes z to the 5th. Okay, and that is multiplied. All right, this right here can come up, so now I've got log 3x minus 1 quantity squared. All right, so now the only thing we have is the subtraction sign, which means division. So our final answer here will be log base 3 of x minus 1 quantity squared on top and y cubed z to the 5th on bottom. Okay. All right, number 11. Number 11. All right, we're going to see that, remember, we know we should recognize immediately about e's and ln's and how they cancel each other out. But we can't do that quite yet. So the first thing we're going to do is move that 2 up there where it belongs, which is as an exponent. All right, so now our E and ln can cancel, and that exponent just drops down. So we're left with 3 squared, which is 9. All right, number 12 is an expand problem. All right, so the first thing I see here is our division. Okay, so I'm going to go ahead and separate that with a subtraction sign. So log base 3x7 minus log base 3 y minus 1 cubed. And then I'm going to take my exponents and bring them down where they belong, which is in the front, making my final answer 7 log base 3x minus 3 log base 3 y minus 1. Okay. Okay. All right, so 13, again, we can, basically this is a rule we have. All right, so what I'm going to do though first is I'm just going to pull this down, pull our exponents to the front. Harper. See what she wants. All right, so that's going to give me log base 10 is my exponents coming to the front, and then that log 3, remember that's 1. And the log base 10 is just 1. And if you needed to see that, remember, if we were to have log base 10, or log 10, and we set that equal to x, remember, it would be 10 to the x equals 10, so x equals 1. All right, number 14 is an expand problem. So again, we're doing ln's, just not logs, but we do the same thing. All right, so I see the division, so I'm going to start there. So ln x7 minus ln yz to the 4th. And then we're going to start breaking everything apart. So this is just going to come down to the front, and we're done with that. 7 ln x, and we're good. Here we have multiplication. Okay, so I am going to show this, work this step out. So it would be ln y plus ln z to the 4th. That 4 would come down. And then that negative would be distributed. So your final answer here should be 7 ln x minus ln y minus 4 ln z. Okay. All right, number 15. Okay, 15 is another change of base problem. So our base here they want is e, and they gave us log 7 of z. So base e, you just need to be reminded, base e is not a log base e, it's a natural log. So that's just going to be ln z over ln 7. Big over base. All right, 16 is an expand problem. All right, so if I expand here, okay, first thing I see is the division, so I'm going to go log base 3 9x7 minus log base 3 y cubed. All right, now I'm going to recognize this is multiplied. Okay, so put those together. That's going to be log base 3 9 plus log base 3 x to the 7th. Minus, I'm going to go ahead and pull that exponent down, 3 log base 3y. So now the only thing left here is this. However, please remember, if we can simplify a log, we will. So logs are exponents, so the only way you'd be able to simplify it is if it gives you a whole number, at least for me, without a calculator. Okay, so remember this would technically be, and I'll draw it over here just to show you. So this would technically be log 3 9 equals x. Right? So that would be 3 to the x equals 9. So 3 to the x equals 3 squared. So x is just 2. So this whole value here is just 2. Plus 7 log 3x minus 3 log 3y. That 2 is going to be the place a lot of y'all don't simplify. But make sure you do, please. All right, I think I can fit 17. Yeah, I can fit 17 on here. All right, so if you remember, again, log AA. So this could come in front. This is already in front. So if I had 5 log base AA plus 3 log base AA, log AA on both of these becomes a 1. So that's just going to be 5 plus 3, which is 8. Okay. All right, next page. Number 18. All right, log base 3 xy divided by 9. So I see the division first. So I'm going to go log base 3 xy minus log base 3 9. Multiplication, so I'm going to break that apart. Log base 3x plus log base 3y minus log base 3 9. And we know log base 3 9 is in fact 2. So our final answer here is going to be log 3x plus log 3y minus 2. All right, 19. Okay, so again, only thing to do here is to rewrite this. Remember, e and ln are going to cancel, leaving me with 3. This becomes e to the ln 2 squared, and e and ln will cancel there. So 3 times 2 squared, which is 3 times 4, which is 12. All right, number 20. All right, so let's see what we got going. A lot going on here. Okay, so the first thing again, just take it step by step. The first thing I see is this big division, so I'm gonna go ahead and break that apart into subtraction. So log base 4 x7 minus log base 4 64 y minus 1 quantity cubed. All right, so the only thing that can happen here is that 7 can come down front. We're going to do that. So once we get to 7 log 4x on that one, he's done. There's nothing else that can happen with him. Okay, so he's just going to kind of trickle down with us. All right, so now let's work over here. There's a lot still going on here. Okay, so let's break it apart first. Okay, keep it going. So log 464, let me show that work again. So if we have log base 4, 64 equal to x, that means 4 to the what gives me 64. And we know x would be 3. 4 times 4 is 16, 16 times 4 is 64. So this whole thing right here is just going to turn into 3. Okay, this 3 can come down, so 3 plus 3 log base 4 y minus 1. Bring down the minus and the 7 log 4x, and now distribute your negative and you're done. So 7 log base 4x minus 3 log base 4 y minus 1. Okay. All right, 21 is 7 to the 2 log base 7, 5. Okay, again, anytime we see a number out front, even if it's just, if you don't see any log, anything like that, we want to use our log property. So I'm going to pull that up to the top. So 7 log base 7, 5 squared. All right, and there's a rule. Talks about a log a right here. Drops down our 5 squared, which is just 25 is our answer to number 21. All right, 22. Okay, that's an expand problem. I think this is going to take a little bit of room, but that's okay. I've got all this room over here. All right, so we've got log base 3 cube root of x over yz squared. All right, so again, you know, whenever we do these, we don't end up with radicals, so we're going to go ahead and rewrite that radical as x to the 1/3. All right, so I see the big division here, so I'm going to break that first. So log base 3 x to the 1/3 minus log base 3 yz squared. All right, so now I'm going to pull the 1/3 to the front. Okay, now over here I'm going to bring the 2 down. Okay, but I'm not quite done because I still have multiplication right here. So I need to split those apart. However, don't forget they're both going to have this 2. So it's going to be 1/3 log 3x minus 2 log 3y plus 2 log 3z. Okay, now, if you didn't know, if you couldn't see it that way, you could always take this squared right here and go ahead and put it with the y and with the z. In other words, I could have written this log y squared z squared, and then you would understand why they both get the 2. All right, I did leave it in parentheses because I applied something inside with that minus out front. So now I'm going to distribute my subtraction sign. And there we go. Okay. All right, number 23. Where are we at? 23. All right, so another evaluate problem. So we've got e to the ln of 3 times e to the ln of 6 divided by e to the 2 ln of 3. Okay, so top's pretty easy. Remember, e's and ln's are going to cancel, right? So we just have 3 times 6. Don't forget, this becomes e to the ln 3 squared before it can cancel. So divided by 3 squared, which is 18 over 9, giving me a value of 2. All right, 24, condense. All right, so we've got 4 ln y minus 4 ln x minus 6 ln z plus e. All right, so the first thing I'm going to notice, obviously, these are going to go up, and I've got that subtraction sign right there. So if I put all of this together, I would get ln y to the 4th over x to the 4th. So that's that one. Okay, minus, let's move him up, so z plus e to the 6th. All right, so I will work this one out just so you can see exactly how it's going to work. But we've already done this before. All right, so if I put this underneath, right, so we've got ln y to the 4th over x to the 4th all over z plus e to the 6th. So if we keep, change, flip, because that's over 1, you're going to end up with ln y to the 4th over x to the 4th z plus e to the 6th. Okay. All right, 25. So again, we're going to bring that 3 up. And then a, log a are going to cancel, so we're left with 5 cubed, which is just 125. Okay, 26. Yeah. All right, 26. So we've got log y minus 2 log x minus 3 log y plus 4 log z. Okay, there's a couple ways you can tackle this. If you do it the long way, which will be individual, and you can do it that way, you're going to end up having a log y in your numerator and a log y cubed in your denominator, and they're going to simplify. You could also, which is the way I'm going to show you, you could also go ahead and combine log y minus 3 log y in the beginning. So you could have rewritten this problem to just be like negative 2 log x minus 2 log y plus 4 log z. You can rearrange that any way you want to. You could put the 4 log z in the front, so you'd have 4 log z minus 2 log x minus 2 log y. It's not going to change your final answer. It's just whatever's easier for you. So most of you probably would not have recognized that right there, so I'm going to treat it as if you didn't, okay? So I'm going to go ahead and move my exponents. All right, so if I divide here, All right, if I divide here, so I'm not going to do the keep, change, flip. I'm not going to write it out, but this would stay and this would flip. So that would give me y over x squared y cubed. Okay, and the y and y cubed, that's what I'm talking about. Those would cancel, and we're multiplying, so it's going to be log, the z to the fourth would come to the top, x squared, y squared will be your bottom. Again, I could spend another page of work showing you 3 or 4 different ways to do that problem. But let me just show you, I'll just show you real quick. Let me show you this one. I'll just show you one way real quick. So here's what I was saying. Okay, so let's say we did log y minus 3 log y and got negative 2 log y. I'm going to pull the 4. I'm just going to rewrite it. I'm going to pull the 4 log z to the front. Then I'm going to do, I'll just do minus 2 log x next. And then minus, it will be 2 log y. Okay, pull everything up. So log z4 minus log x squared minus log y squared. And then minus means division, so log z4 over x squared. And then again, that would say keep, change, flip, so that's going to become log z4 over x squared y squared. So you get to the same place. It just depends on how you do it. All right, 27. All right, find the inverse. So remember, finding inverse, we are switching x and y and resolving for y. So right now we have y equals 4 log base 5x. All right, so we're going to switch that. It's going to become x equals 4 log base 5y. All right, pull your exponent up. All right, and remember, once we get to here and it's equal to x, we want to left, right, center this. So I'm going to put that, remember, we can't left, right, center unless our log is on the left. So I'm literally just pushing him over there. So it's almost like he's not over here at all. So left is 5, right is x, and center is y to the 4th. Which is not what I want to do. Boo. That was stupid. I mean, I can do it this way. You'd have to take the 4th root. And if I take the 4th root, you'll end up, I can do that. I'll show you that way, and then I'll go back to the other way I would have liked to have done it the first time. It's okay. All right, if I take the 4th root here, right, obviously we're not going to leave that radical there. So remember, that's like 5 to the x to the 1/4 power, which is the same thing as 5 to the x over 4. Okay, so that is one way we could have done it. The other way I should have done it, don't know why I didn't. At this point right here, I should have just divided by the 4. And then left, right, centered. So this will be equal to x over 4. So 5 to the x over 4 equals y. So F inverse is 5 to the x over 4. Either way, we get to the same place. I just had to take the 4th root versus just dividing by 4 to begin with. Whichever one you like. All right, number 28. Again, find the inverse. All right, so here we go, 28. We've got y equals 4 to the x plus 2, so that's going to turn into x equals 4 to the y plus 2. Again, we don't want the left, right, center equal to x unless it's on the left, so I'm just going to switch that around, not changing anything, just switching it around. All right, so now we can left, right, center, and to get y by itself, we're just going to subtract 2. So it's going to be 4 to the x minus 2 is going to equal y, so our inverse is 4 to the x minus 2. Who's that? Harper. Who's that? All right. All right, number 29. 29. Okay, so I'm going to actually have to put this one up under the Elmo because I didn't well, I guess I can, we'll see. A second. All right, so 29, we're right here. I'm just putting it on here so I don't have to rewrite every single one of these. Okay, so for 29, okay, they gave us this function up here. I'll copy it. All right, so remember, the first thing we're looking at, they're talking about domain, range, vertical, and horizontal asymptotes. And then we want to know if we're increasing or decreasing, and if we're concave up or down. All right, so let's talk about what we know here. All right, so we know our A number, which is number in front, is 1. So our A is greater than 0, and we know our B is between 0 and 1. Okay? All right, so if we were doing exponential, all right, if we were doing exponential, not logarithm, if we were doing exponential and we had this information, A is greater than 0 and B is between 0 and 1, we know that would look like this for exponential. Okay, so remember, logs and exponents are inverse functions, which means they flip, okay, like such. So this is the log right here. This is what the log would look like for this function. Okay, does everybody see that? So that's flipped over this line. All right, well, our domain depends on this number right here. So if that is a -4, that means it was going to be shifted to the right 4, which makes our domain 4 to infinity. Our range is always negative infinity to positive infinity. Your vertical asymptote is whatever this shift is, so x equals 4. There is never a horizontal asymptote for us in log functions. Okay, because the horizontal asymptote turns into a vertical asymptote for us. All right, increasing or decreasing. All right, if we are between 0 and 1, we are decreasing. And then this is still concave up. Okay. You can pause the video there if you need to go back. I'm going to keep moving so I can get done. Hopper is officially the slowest hole puncher in the world. Bliss. All right, number 30. All right, so we've got f of x equals log 3x plus 6. Okay, again, we want the domain, the range, vertical, horizontal. We already talked, this is none. Increase, decrease, and concave up or down. All right, so let's talk about what we've got. This time, our A value is still greater than 0. And this time our B is greater than 1. So if A is greater than 0 and B is greater than 1, on an exponential, that will be our growth formula. Okay, so if we flip that, it's going to look like this. Is everybody with me? Okay. All right, so our domain, again, depends on this number right here, so it's going to go from -6 to infinity. Okay. And then our range would be infinity to infinity. All right, vertical asymptote is going to be x equals -6. No horizontal asymptote. All right, so this time we are still increasing, right? We're still coming up. So we're still increasing, but we are concave down. That starts our downward. We're still increasing, but we're concave down. All right, 31. Getting towards the end, y'all. 31. All right, so they want to know if they're inverses of one another. So remember, we have to plug them into each other. All right, so 31, we've got the first one, f of x equals log base 3, x minus 4. And then we've got g of x is 3 to the x plus 4. All right, so first thing is f of g. So we're going to put g into f. Okay, so immediately the plus 4 and minus 4 can cancel. So now I have log base 3, 3 to the x. Remember that x can come to the front. And then log base 3 of 3 becomes 1, so we just get x. All right, then we're going to put f into g. All right, so remember again, if you have a and log a, those are going to cancel. This is just going to come down. And then minus 4 and plus 4 cancel, so we have x. So yes, f of x and g of x are inverses. All right. 32 asks, use the table to determine if the function is exponential, logarithmic, or neither. Okay, so on 32, we notice that we are adding 1 on the left and we are multiplying by 2 on the right, correct? So if the x's are same interval and then we're doing the multiplication over here on the right, that is going to make it exponential. So number 32 should have been exponential. And you'll see my, I'm not going to write out my explanation for that, but basically your input values are equally spaced by 1 and output values are proportional by 2. That'll be on my answer key that I post as well. Okay. All right, 33. Same thing here. Okay, but this time you're going to see here we are dividing by 2, and here we are adding 2. So remember, we want multiplication division to be on x for logarithmic and the add subtract to be on y. So that does work out here, and that does make that logarithmic. Okay. All right, so number 34 is the last one, and it is a final inverse problem. So let me get to a new page because I never know how much room that's going to take. All right, final inverse problem for number 34. So f of x equals log base 5 x plus 7, and then g of x is going to be 5 to the x minus 7. All right, so g into f. Okay, minus 7 plus 7 goes away. Log base 5, 5 to the x. Bring the x down front. And log 5, 5 becomes 1, which just gives me x. All right, f into g. Okay. A log A becomes 1. So basically they cancel each other out. Which gives me x, so they are inverses. Okay? All right, so again, my answer key and the blank will be posted in Canvas under the module for Friday, in addition to some of this work. And then you can watch this video, okay? Don't forget the quizzes tomorrow. Also, double check on your notes because you do have a notebook test. Who knows how long I'll use this video, so I'm going to make sure I say in the fall of 2025. You have a notebook test on Wednesday. That's just where you have to turn in 2 sets of your notes, whatever 2 I ask for on Wednesday. So double check, make sure you have all of those. If you need any of them, you let me know on Tuesday, okay? All right, see you all tomorrow.